The first is we're going to take a quick look at the data services landscape. So I'm going to try and describe and define data services even further so that we know exactly what we're talking about with data services, and then we'll take a quick sort of scan at what's available today. And in the second half of the talk, given that this is a talk about building apps, we're just going to build an app. We're going to start with something that we all may be already familiar with, just a basic 3-tier website, and we're going to see how we can start using data services in sort of real-world scenarios to help us build either richer experiences in our application or help sort of offload some of the challenges that we have when building web applications. So along the way, we're going to touch on a lot of the new stuff that's come out, either just recently RTM'd with Silverlight 2 or the .NET Framework 3.5 SP1. We'll also talk about some new service announcements that were made at the PDC, and then look ahead at the product roadmap and sort of look longer lead what's going on in this space. And then at the end of it, if you're still awake and I haven't bored you by then, we'll talk about how you can get even more involved in the product if you want to help shape where we're going. So let's just jump right in. And so as an app developer, if you sit back and look at all the data services that are available, what you end up seeing is that there's a spectrum of services. And they range from domain-specific services on one end of that spectrum all the way through to building block services on the other end. On the domain-specific end, there's things like Popfly services. If anybody's familiar with Popfly, it's an online tool for creating mashups. They expose data services for consumption via external people. One of the services they expose is crime statistics. And you can take those stats, mash them on an app, and see all the bad stuff that's going on in various areas. And so a very specific set of data that they expose through their service. On the far end of the spectrum, we have things like Windows Azure services and Windows Azure table services, SQL data services, and a number of the other sort of low-level building block services that we've announced here at this PDC. And to pick on one of them, let's look at SQL data services. SQL data services, as you may have seen already, is effectively a database in the cloud. You can push your data up there, query your data, pull data down, update data, and the idea is that that database in the cloud is running on Microsoft's data warehouses that are sort of geolocated around the world. And you push off the problem of your data store and scale out to SQL Server data services. And the idea is that you're going to then use that service in your application to sort of build a richer client experience on top of it, right? So we have a spectrum of data services. And for the context of this talk, when we talk about a data service could be something you create yourself, or it could be something being exposed by a third party. And what I mean by a service you create yourself is that, as we can see along this spectrum, there's a little pink box called ADO.NET Data Services Framework. This is a framework technology we recently released with the .NET Framework 3.5 SP1 that makes it really, really easy to take your own data and expose that data up on the web as sort of a true service tier for consumption via your own apps or others. So all the services on the spectrum, you could create domain-specific or building block services using that framework technology, or it could be a third-party service. And what I mean by third-party is basically you're a client of somebody's service. You don't know how it was implemented. You're just consuming their data. And additionally, each one of these services could be on-premise, or it could be up in the cloud. What I mean by on-premise is if you create your own service, you may be in the business of running that service on your own local infrastructure, so your own your own web servers, and in turn, your own hardware. If you want complete control, that's one way to go. Another way to go is to take your services and then push them up into the cloud and sort of have the scale out of the cloud sort of on your side when you're running your services. So there's a spectrum of services. These services can run in many different contexts. They could be created by you, could be created by others. And the last point, and probably the most important point of this slide, is that the interface into these data services is, one, a simple REST interface. And we probably all saw that when we attended Don's talk a second ago. And two, this is the important part, is that the interface into these services is uniform. And what I mean by a uniform interface is that how you interact with these services, each one of them on the spectrum, whether it's yours or somebody else's, how you interact with it is uniform, meaning when you look at these services from a developer perspective, you can learn how to use one and then apply that learning to each one of the services in the spectrum. So how you query data in these services, how you insert new data, how you update data, how you delete data, use all the same semantics when you're working with these services. Obviously, the data being exposed by each of these services is going to differ. And each of these services is up for a different reason. But the idea, again, is that the interaction with those services, the semantics you use to interact is the same. The addressing scheme, how you specify the action you want is the same. And again, why this is interesting is that, again, you can have knowledge reuse across services. But now what we can do is we can say, wouldn't it be nice if we could create reusable developer tools, reusable reporting tools, reusable client libraries, UI widgets, et cetera, that all understand these uniform conventions. Now we can get to a world of code reuse against services in the cloud, just like we're used to code reuse today, maybe when we're talking to a local SQL server. And we're all used to using common APIs and developer tools. Wouldn't it be nice if we could get that same type of efficiency against cloud services? And so these are the types of things we're going to explore today. And so to pick on two of the services that were on that spectrum, the first is an ADO.NET framework-based data service, so an on-premise service that I've created previously and is running on my laptop here. And so I have SQL Server running, I have the services framework running, and I'm exposing a local service on-premise right here. And another service that we're going to look at is a SQL Server data services service that I've gone off and done sort of the account creation dance and all that beforehand and populated some data up in my cloud account. And now what we're going to do is look at both of these services in turn from the client perspective, or from you, sort of the developer writing an app against these services. And the first thing that we're going to see is what I mean by this uniform interface. What does it mean to interact with these services using the uniform interface? So let me jump out of PowerPoint and get into our demo here. So hopefully that's come up. Great. So what I have right here is VS 2008 SP1. I've pre-created an ADO.NET data service. This is my on-premise service. And we'll talk about how I created this and whatnot in a second. But the premise here is that I've got a service. The data being exposed by this service is just a basic students and classes schema. So students participate in classes, classes have students, so on and so on. So let's look at this service in the browser and see what we mean by a uniform interface. The reason I'm going to hit it in the browser is that, again, the interface into these services is just simple HTTP. So hopefully by using the browser, it proves to you there's no magic here. And what we're looking at is the root of an ADO.NET data service. And more specifically, we're looking at an Atom service document. So as you've seen, these services by default use Atom. Atom became kind of popular with the sort of invent of like blog syndication and whatnot. And it turns out if you take Atom, you pair that with the Atom publishing protocol, you get a nice standards-based two-way data exchange protocol. So the system's based on Atom Pub. And what we're looking at is an Atom Pub service document. The service document says to you, there's a number of sets of data you can work with. And the way the system works is you look at the sets that are available, classes, students, class registrations, and so on. And if you want to navigate to it, you build a URI using the relative URI given back to you. So if I want to work with classes, I'm going to go to this relative URI right here. And so what I'm going to do is append that onto the base URI that we have. Zoom in so folks can see I'm just appending classes onto the end. And now I'm effectively asking the system, give me back all the classes that you have in your underlying data source. So I've asked my on-premise service to query all the classes. And what we've gotten back is a feed with many entries. And so let's dig into this a little bit more. What Atom Pub says is anytime you're working with a collection of data, a collection is represented as a feed element with many entry elements. So in this case, every class in the system is represented here as an entry element. So you can see there's a number of classes. If we dig into this payload a little bit more, Atom Pub says that you need to identify every element in the set uniquely. So this is how I identify a class, just via URI. Atom Pub also says if you want to work with a particular class, you follow its edit link. And so if I follow this edit link, what I'll get to do is address the class specifically. And so what I'm going to do is copy up this relative URI into my base URI. And effectively now I'm filtering my query from the set of all classes into a particular class, in this case the class identified by key value 3. And so now we can see we're working with just one class. And there's all the class information down here. It's called Golfing for Dummies and whatnot. And the final thing is that we can see there's another link element here. And the link elements are something in Atom Pub that let you say that this entity, this class, is related to something else. And so associations are also a first-class concept in these data services. And so if I want to walk over this association to get everybody that's registered in this class, I go to the relative URI here. So I'm going to pen that on just quickly. And now we're looking at the collection of all people that are registered in the particular class. You can see not a very popular one, only 3. And so let's roll back to this class and roll all the way back to the set of classes. We can see that there's many. And there's a number of other things you can do in the URI space to explore data in a service. We'll talk about more of them in just a second. But one of the things you can do is you can say, I want to specify a simple filter criteria, and I want that to be such that I only get back the classes that are golf related. So let's zoom in and look at what the URI is that I've typed. You can see we're filtering the set of classes, getting back only the things that are golf related. So if I hit go here, we should have fewer classes. So let's see, we've only got 3. And if I look at the middle one, yeah, this one's golf related. If I look at the next one, this one's golf related. And you're just going to have to trust me that the last one is as well. So that's a quick way to see how to work with this on-premise data service that I've created. So far, we've just been building URIs and querying our on-premise service. What I'd like to do now is flip over to the pre-created SQL data services service that I have and see how the semantics, the set of patterns that I use to work with that service is the same as the service that I've created locally running on this box. So I always forget my URI here, so let me go grab it. And I'm going to paste it in, and we'll look at it in just a second. OK, we've got a WordPad issue here. Sorry, I'm running a new build, so sometimes the copy-paste breaks down for me. So let's try this one more time. All right. Hopefully this is the one. So now we've got a class. There we go. And it does basic HTTP auth. And let's just zoom in on the URI for a second to see what it looks like. You can see I'm addressing something in data.database.windows.net. It's just a pre-created SQL Server Data Services account that I've got. And we're addressing the /entity set. Data services, as Don explained, uses a flexible storage model by default, so we're working with sort of a property bag here. But the key is the same, is that when we address a set, we get back a feed of many entries. When we drill into one of those entries, we're working with a particular class now. The same as before, a class is identified via URI. As a consumer, it doesn't matter to you what that URI is. It's an OPEG token that uniquely identifies the class. As before, we can see there's an edit link. And just as before, the same way that we filtered from collection to singleton, we can do that again. This time I'm going into class with key CS10. And now we've scoped the set of all classes to a particular class, just as before, right? And we can continue to drill down as we've done before. And so if we roll back, the same way we filtered our on-premise service, I can filter my service in the cloud by saying $filter equals subject is equal to golf. There we go. So now we're looking again at a set, a smaller set. There was 3 before, 3 here, because we're working with the same data set. And we're working with a set of classes. So that's a very quick tour of what it looks like to query both an on-premise service and a remote SQL data services service. I'm going to show you one more thing by going to, again, my on-premise service and running a little tool that lets me control the browser a little bit more. So generally, the browser just does HTTP GET. Now I can do a few more things. And I'm going to address the on-premise service that we've got, looking at the classes set. And let's look at class 3. And if I change the HTTP verb, so far the browser's just been doing GETs. And that's mapped to a query operation to these URIs. If I change the verb to put, post, or delete, that's going to change the action. That's going to change it to either update, insert, or delete. And then finally, just using standard HTTP content type negotiation, the same way that a browser asks for an image versus an HTML document, what I can do here is I can ask the remote service, give me back that data, but I don't want it using XML, angle brackets, and whatnot. I want a different format. In this case, I want JavaScript object notation. And so the idea here is that we can work with these data services and ask for the format that suits our needs best. And so this time, I'm going to address the class the same way we were addressing a second ago, but this time get a different representation back. So I say go, and now we've gotten back a JavaScript object notation response, something that we can easily work with from, say, an AJAX-based application. So let me jump out of here quickly. There we go. And flip back. There we go. We back up. Great. And so that was a really quick tour of what it looks like to work with 2 services that are running in very different environments. One I created, one that's hosted up right now in Microsoft's data center. And the idea, again, is that it's a uniform interface into these services, allowing us to reuse our knowledge and to reuse our code. And so we looked at a number of URI conventions that we can use for interacting with these services. These are a bunch more conventions that these services support, just because I didn't have time to show you them all. The idea here is that there's many more presentation options that support paging and eager loading of associations and deep traversal of associations and so on. All the things you may want to do from an application when you're working with these data services. And so we went really quickly into sort of the details of a service and worked with a few of them. And so what I want to do for a sec is step back and formalize what we just looked at. In fact, formalize the interface into these data services. And so the first thing is that what's underlying each of these services is a data model. The data model that we use is the entity data model. The entity data model basically specifies that there's collections of entities, entities themselves, and relationships between entities. An entity here is just a customer or a class or a student. And we chose this data model because it maps pretty well to how we think about the web, right? Just resources and links between resources. And so from a developer perspective, you might be wondering, why do I care that there's a data model underlying these services? That didn't really surface up to me there, did it? And the reason you care is just like SOAP services today have a WSDL document to describe RPC endpoints and actions you can take against these services. For data services, we also want some type of description language. And the reason that we don't just reuse WSDL and we use something like EDM is that we're working with pure data services. And so instead of being able to describe a remote method, we need to be able to describe the entities, the shape of the data that we can work with each one of these services. Once we have a description language, like the EDM in this case, we can teach developer tools, client libraries, and whatnot to sort of to inspect that data model and then create richer experiences for us. Just like you can consume a WSDL document, create a service proxy, you can consume an EDM document and create a service proxy for data-related services. So now that we have an underlying model for these services, effectively, the way we've been interacting with the service is simply by having each one of those services automatically generate for us a unique URI that points at every aspect of those data models that we may want to get at. So when I was saying /classes and then /classes3, effectively I was addressing parts of the data model. I was saying, give me back an entity set, then scope that set to a particular entity, and then traverse a relationship between entities. And so it's very mechanical on how you build out or how you address the data model. And because the model is sort of shared across these services, we can address the data in each one of the services on that spectrum in the same way. So now we know how to point at data in the particular model, how to build out URIs, and we just saw it. Again, as we showed, the way that you specify what action to take on the data that you're pointing at is just through simple HTTP, gets, puts, posts, deletes, mapping to the various operations, query, insert, update, delete, etc. And so as you can see, we have pretty tight integration with sort of the core concepts of the web, URIs, HTTP, etc. The reason why this is interesting to you as a developer is that, firstly, if we have this type of tight integration with HTTP, you can make use of all the HTTP infrastructure that's already deployed at large on the web. And what I mean by that is you can make use of HTTP caching infrastructure, HTTP authentication infrastructure, CDNs, and so on. And finally, as we saw, the last question, once you can address data, once you can specify what to do, the last question is, what does that data look like when it comes back? And the idea, again, here is that because we have a data model and we're addressing items in that model, we can ask to have that model projected into the serialization format that works best for our needs. So if we're on a full-fledged, maybe .NET platform talking to one of these services, we can ask for XML and use all the rich XML APIs that we have to consume an Atom Pub response. If we're building an AJAX-based application, we probably want a JavaScript object notation response because it's really easy for us to consume that inside of that platform. So the idea here is a format's a tool. You'll ask the system to give you back the format that you can most easily work with. So we did sort of the quick lap around data services. We talked about what's available, and we talked about the different types of services and showed you could create your own or use ones in the cloud. And that the interface into those services is uniform. In the next part of the talk, what I want to look at is actually building an app. We're going to start with a basic 3-tier ASP.NET web application. That app is going to be a web app for a university. And so the idea is that students can log in and see what classes they're taking, administrators log in and manage students and whatnot. And then to that, we're going to see how we can build sort of some richer experiences on top of that site using some of these data service technologies that we've already looked at. And so the idea is that many of us probably have built a lot of these basic or these traditional ASP.NET 3-tier web applications, or we're maintaining some today. So we're going to see how we can sort of evolve and pull in data services incrementally as it makes sense to us. So standard picture, right? 3-tier architecture, basic website. We all know the dance here. A browser makes a request to a mid-tier. The mid-tier web server churns a little bit, maybe grabs some data from a SQL server, churns a little bit more, responds back with a very nice package of presentation information, data, and behavior all bundled up into one, right? Just described how we access web pages, right? Nothing new here. And what we're going to do is say, given this online university site that we've got, maybe we want to build a richer user experience. We want to go and use Silverlight to build a very dynamic experience. And so what would happen if we went and built the Silverlight head for this site? And if we did that, sort of the data access changes a little bit. Again, nothing new here, but it's interesting to look at what's changed. So the interaction pattern is client makes a request to the mid-tier. Mid-tier responds back now with just presentation and behavior, effectively the contents of the Silverlight app, the ZAP file, right? And once you've got that app, it's not until the user starts working with that application that the Silverlight app needs to turn back, potentially across the web to the mid-tier where the app came from, and get the data to drive the user experience. So what we're going to do is look at how we can use the data services framework to easily create a data service that's going to make it super simple for us to consume data that may be coming from across the web from our Silverlight applications or rich internet applications. So first thing we're going to do is look at how we can build on-premises services to drive data access from rich internet applications. And many sites today that I look at are more than just a single user experience. My favorite example is Facebook. Facebook has a bunch of information about me, my friends' friends, pictures of us, and everything else, right? And they have a pretty nice social networking experience on top of that data. But they house a bunch of data. They're effectively a data platform, and they expose that data through APIs for third parties to consume and build their own experiences on top of that data. So they're kind of a hybrid site. They're both a data platform exposing their data that they're managing, as well as sort of an app that is consuming their own data source. So maybe in the context of our university, students want to be able to start consuming their class list, what classes they're taking from their cell phone. And so now we need to be able to drive the data access for other form factors like cell phones, as well as provide a rich experience for our Silverlight app. Maybe there's a third-party website out there that exposes what classes each university is offering. Me being an admin of this university, I want to be able to expose my data to that third party such that they advertise my university as well. And so basically what I'm saying is now in the mid-tier, we truly need a data service, where service is sort of the formal sense, right? A service boundary to expose our data. And so what we're going to look at is how we can build that on-premise service very easily and consume it from Silverlight. So first step is to create an on-premise service. So let me switch back into the demo here. And I'm going to go into the basic 3-tier website that we have. And I'm just going to run it quickly to show you what we've got. It's all set up with all the ASP.NET bells and whistles already, so the ASP.NET membership provider, role provider, forms auth, all that kind of jazz. And so I'm going to log in as an administrator. And standard stuff, right? Basic website. I've logged in as an admin. I can look at my course catalog. There they are. I can sort my courses and manage them, delete them, all that kind of good stuff, right? So the premise here is that we want to build the richer experience for our Silverlight apps and for other parties to be able to consume all of this data. So now the first step we need to do is build our on-premise data service. And so to this project, we're going to say add, new item. And we're going to select ADO.NET Data Service. And we're going to call it Contoso. Yes, Contoso is back again. So here we go. And what we've had created for us is the skeleton. Let's get rid of some of this goo here. Go away. There we go. Is the skeleton of an on-premise data service. And so what we're going to do is get rid of a bunch of these code comments quickly. And the step that we have to do is hook up the skeleton of this service to the data model this service is going to expose to the web. So hook up the service to the data model it's going to expose. I already have a model created in this application. It's right here, the same model we were just working with a second ago, so it's already familiar to us. And how I've done this is I've used the ADO.NET Entity Framework to create this model. For folks who aren't familiar with the Entity Framework, the 2-second spiel is that the Entity Framework makes it really easy for me to create a conceptual model on top of data that's in a database. And it doesn't matter how that data is stored or among many tables or whatnot. The idea is I can create a conceptual model that makes sense to me that I can work with. One of the ways I can program against that model is have the framework automatically create for me .NET objects for every entity in this model. So beforehand, I've created the model, and I've had .NET objects created for every entity in this pretty boxes and lines picture here. So we have a student class, class registration class, and so on. And then one class that represents this model as a whole. And so what I'm going to do is hook up the service to the class that represents the model as a whole, which is records entities. And then the whole thing is secure by default, so we have to start opening up access to things in the model. I could start typing all the collections that I want to have access. I'm going to take the really fast demo feature here and say everything in the model is available for all read, all write, but we could get more granular here if we wanted to. And at that point, we're done. So let's bring this guy up. And now let's quickly look at this in the browser and see what we've got. So the idea is we're creating an on-premise service that's sort of a true service tier to expose our data to our application and others. So here we are back at the root of the service after we logged in. Looks exactly the same as the service we played with a few seconds ago, right? That's because it is exactly the same. Basically, that's all it takes to get a data service from a model up to a service tier. And the idea is that all the URL tricks we looked at, HTTP puts, posts, deletes, full read write, just works now against this service. So we've got an on-premise service created like that. And so if I flip over to my slides, are we back? Great. So we created the on-premise service. I'm going to take a little aside and talk about refining access to the service. Because usually once I show this to folks, the first response that I get is, that's cool, very nice, but now I've got a big, huge hole into the database and it's exposed to the web. Like, let the nightmare begin, right? So what we're going to do is look at how we can refine access to this service. And we're going to see how these on-premises services natively support and make it really easy for me to support sort of versioning, concurrency control, etc. But the one thing that I'm going to code in today is show you how to hook up an authorization policy to this service and authentication and so on. And the premise that we're going to follow, let me flip back into the code. The premise we're going to follow is that we have made all this investment in our previous 3-tier website, that Contoso University website. As I said, it was already hooked up with all the ASP.NET bells and whistles, membership provider, role provider, and so on. So I want to be able to reuse that investment with my new on-premise data service. So we're going to hook up the data service to the existing investment we had with authorization. So let's move this guy aside so we have a little more room to work with. And the way that I do that is I start adding interceptors into my service. So let me grab a few so we don't have to watch me type. There we go. I'll paste them in. And I'll collapse these so we can see what's going on. There we go. So we have one interceptor here called a query interceptor. The idea is that this method is going to get invoked every time the on-premise service receives a query request for students. It doesn't matter how you landed on that student, what URI path you got to a student, this guy's going to get executed. So you're out of the business of trying to parse all these URIs and whatnot, and you get to work just with the conceptual entities in your model. And so here we're saying anytime a student gets queried, run this code. At this point, I'm doing a role check, and this is where I'm hooking up to the existing ASP.NET role provider infrastructure, and I'm saying if this query for student comes in from somebody who's authenticated and in the administrator's role, then don't do much to it, just let it flow through. If the query isn't from somebody in the administrator's role, then that's where I want to take some action. And the idea here is that conceptually, the system has taken in a request for students, and the analogy is kind of a SQL statement. It's not SQL at this point, but that's the analogy. And you can imagine we've got a select star for students at this point, an in-memory representation of that. You now have a chance to take a predicate, a where clause, and append that onto the query. We'll then fold that where clause into the query that we're about to execute and take that whole thing and push it down to the underlying store. So push the whole query down to the underlying SQL server that knows how to execute queries best. So if you followed, basically what we have here is a very efficient and simple way to implement row-level security. And so what's going to happen is that now when I try and query, if I'm not an admin, I only see my own record. And if I am an admin, I see everybody's record. So very quick and easy way to implement row-level security and hook up to the existing investment we had with the ASP.NET membership provider, role provider, and so on. And so that was looking at how to lock down query access. If I look at how to lock down change access, meaning anytime somebody tries to change a student, update, insert, or delete one, this method is going to get called. It looks pretty much the same, right? If you're an admin, you can do whatever the heck you want. If you're not an admin, you can't do anything, meaning you can't change any students. So that's the security policy we've just implemented, and we've hooked this service up to the existing investment from our 3-tier website. So that's where we're at so far. We've refined access, added an authorization policy now to our service. And so let's go back into the slides, see what we want to do next. So last step, finally, we're going to consume this service from Silverlight. And we're going to see how we can make use of the fact that there's a uniform interface being exposed by this data service from Silverlight. So let's go build the Silverlight app that's going to consume this service. So flip back into our code. Great, we're up. We're really testing this switcher box here. Let me save this guy off. I think I need to add one using statement here. There we go. Let me come up with Solution Explorer. And I already added in a Silverlight app beforehand, so we didn't have to watch me do the whole add new item dance. And what we've got here is a basic Silverlight application, and I've pasted in some XAML, and the XAML basically has got a skeleton of a site. And what we're going to do is write the data access code. We're going to consume the remote service to populate the list of students using just a basic sort of list. And then every time we click on the student, we want to go fetch that student's information dynamically and bind that data onto the data grid that's going to show all the classes for the particular student. So now what we've got is, again, the skeleton of our site. We need to go implement the data access to actually consume this service. So for folks that are used to consuming services from Visual Studio, you're generally thinking, the reaction here that I want to take is add a service reference to my service. Well, that's the right thing to do because we've taught the service reference gesture about data services. And so if I added a new reference, I could type in a URI here to any data service that exists on the spectrum, but I'm going to make use of the fact that I already have one locally, so I've discovered it local. And if I hit OK, it's going to generate me a service proxy to talk to the service. And I've already done that, so let's look at what got generated. Let me drop this down and zoom in for us. What we had generated was one class called records entities, which represents the service as a whole that we're going to talk to, and one class for every entity type that exists in that remote service. So pretty simple stuff so far, right? And the last thing I want to point out is that let's see that this records entities class is, where are we here? I want to go right here. This records entities class is derived from the data service context class. And so basically, the add service reference has added a little bit of sugar because it's understood the remote data model. It pulled down the EDM document, inspected it, and generated me a derived class of the base class data service context. And so I can work with the derived class here, or I could work with the base class. In this context, we're going to work with the derived class. In a second, I'm going to show you how to work with the base class against any service on that spectrum. So that's what we've had generated through the service reference gesture. Now we need to start hooking up to this Silverlight app to the data service. So let's go to the code behind for this page. First thing I'm going to do is instantiate that service reference that we've got. So let me grab some code so we don't have to watch me do this or type this. Here we go. And we'll paste this guy in right here. And so we've instantiated that proxy. We've pointed it at the on-premise service we created earlier. And here we're issuing an asynchronous query for all the students that are being exposed by the remote service. And then in the callback, which I've just defined in line right here, I'm going to bind the results of that async query to the students list that we saw in that sort of the XAML preview a second ago. So that when I load this app, we're going to query all the students, bind the results to the list. And you're probably thinking, man, you're just working with like .NET code here. What happened to all those URIs? Because the interface into these systems is uniform, we're able to teach the client library about those uniform interfaces. So these calls are all being mapped down internally by the library just to HTTP gets, puts, posts, and deletes against the sort of the standard URI scheme that we looked at. And so we're actually leveraging the fact there's a uniform interface into this on-premise service. So we could take this code and point it at a different service, and it would just work as well. And so here we go. Now we've got the student list populated. Our last step is to populate this other handler that I've got, which is empty. This handler gets called every time one of the students gets clicked in our list. So what we have to do is fetch the classes that that student is in, that currently selected student. So let's get the code for that. We're running a little short on time, so we'll just paste it in. Here we go. And what I've pasted in is some code that gets the student that was just clicked in the list. And once I've got that student, I'm going to create a link query. The link query says, give me back all the registration, all the things all the classes that student is registered in. And again, here we're making use of the fact that there's a uniform interface between the client and service. What's going to happen under the covers is this link query is being translated into a URI. And the way we know how to translate from link to URI is because it's a sort of a uniform interface into these services. Now we have the ability to remote link queries against remote data services. And so this query isn't being running locally. This isn't a link to objects query. We're literally remoting this query to the data service that in turn is going to push it all the way down to the underlying store. So complete query push down, very efficient way to get just the data we're after. And we're doing a little trick, casting it to data service query, because I'm going to eagerly load a relationship. I'm actually working with two entity sets here, but I'm eagerly loading in the class set so that I only make one round trip to the service to get all the data I need. And then on the way back, I asynchronously query this, and on the way back, I'm going to bind the data to the class's grid. Standard data binding that we're all used to doing. Now we're binding data from a service to our UI. So let's run this guy, and if all went well, we should now have a Silverlight app talking to our service that's interactive. As we click it, it goes and fetches data from the remote service. So we're going to log in as an administrator, so all of our authentication stuff that we added doesn't kick in. I'm going to go to the Silverlight app, and now we can see we have a list of students. If I click me, what's going to happen is we're going to go get all my class data. So let me just set a breakpoint in here, and I'll show you why in a second. And if I click myself, I hit the breakpoint. Let's just go through. And I can see all my class information has come up here. And you can see all the classes that I'm in. I did well in some golfing classes. I totally bombed on coming up with fake names. That's why we have to live with Contoso all over again. And if I zoom out and I click on Pablo, he's an architect on our team. He's only taking 2 classes, so he's slacking. And click on me, we go get my classes again. And what's happening is I just set the breakpoint on that click handler. And the reason I set it is if I mouse over here, this is kind of a first row only experience, but let's see if we can zoom in on this guy. Here we go. We can see the link query got translated under the covers by the library into one of those URIs. And it looks just like the URI we were typing into the browser ourselves. So we're exploiting the fact that there's a uniform interface into these services, and we're remoting that query to the target service. And so again, since the addressing scheme against each of these services is the same, we can have sort of these reusable client libraries talking to different services. So let's not save this, remove this guy, run, and we're all good. So that was a quick example of how to expose data that in a way that's rich enough to power sort of your Silverlight applications, also rich enough to sort of expose your data for consumption via third parties, but also in a secure way. And so the last deal is that notice this graduate button here. I'm not going to tell you why we have it here. I know it looks completely out of place, but that's going to help me segue into the next demo. So just remember the fact we had this graduate button that does nothing right now. So let's close this down. And we can close this guy. Actually, let's leave this guy open. And flip back into slides and sort of recalibrate ourselves and see where we're at. So we created this. We used an on-premise data service as a very powerful way to sort of drive our data access for rich internet applications. That was just something we were running on our own infrastructure here. Now what I want to do is flip our focus from client to mid-tier and now look at mid-tier to back-end interaction for this service. And so to put this in the context of the university site that we have, think about what sort of the data set of a university would look like. You have a bunch of students. Students keep graduating. Every time they graduate, they become an alumni, right? Let's assume that my university doesn't have a graduate program. So I just keep graduating students, and I keep building and building and building the set of alumni. It's just ever-increasing set. It tends to be a cold set of data because I don't have a graduate program, but I have to keep those records around, right? I have to back them up. I have to keep them available for when I need them. But it's an ever-increasing set, and I use it seldom. On the flip side, the active students are the students that are always working with the site. It's hot data, and it's a stable data set, right? Because my university can only accommodate so many students at one time. And so the idea here is that I could keep the infrastructure the way it is, the same picture we've got here, and build out my back-end store as my data grows. And that's a completely valid option for me. And I can do that using SQL Server and all the rich tools that are provided with SQL Server, right? And if I want full control, that's one way I can go. Another solution I could take is say, I don't want to deal with the fact that I have to sort of build out my data tier as these alumni keep growing and growing and growing. I don't want to have to keep building out my storage. I don't want to have to keep sort of scaling my infrastructure so that I can make these alumni available. And so what I can do is I can move that archive data, those archived alumni, from my local store into cloud storage. And the idea is that I can use those building block services, the Windows Azure services, SQL data services, to sort of archive that cold data off into the cloud, that data set that keeps increasing. And now I'm not in the business of having to scale my back end with this ever-increasing set of archived data. And so what we're going to look at is how we can take our application and sort of enable that scenario with the app we've been building so far. And so what I'm going to look at here is the first step we're going to take is when a student moves from active to alumni, we're going to see how we can use a building block service. The service we're going to use is SQL data services to sort of archive it into the cloud. And excuse me. And in doing this, we're going to see again how we can exploit that uniform interface into all of these services. So let me jump back into Visual Studio, and let's actually implement this, this move into our application that we have. So the first thing that I'm going to do is I'm going to go paste in a few helper classes just to get things moving along. So let me go down and grab a few of these guys. There we go. And move down here. And I'm going into the mid-tier code. So this is the code for the on-premise service we created just a second ago. And I'm pasting some helper classes into the bottom. There we go. So you can see just a pretty vanilla class called Cloud Student. It knows how to translate between a student to a cloud student. I've done this so that when I write the rest of the code, it's really obvious where people are going, because we're using the cloud and local stores and whatnot. So cloud students are going to go into the cloud. Student classes are staying local. So little helper class to get us going. And now I'm scrolling up to that change interceptor that we defined earlier. And because we're using just data services, and we've got a model behind these services, what we can do is we can model this change, the move from an active student to an alumni, just as a state transition. And so in our interceptor here, we're going to say anytime a request comes in to change a student and change their state from active to alumni, I want to archive that student now into the cloud. And so I'm going to add in some code that says if the student that's coming in, that's a changed student, if the grad date is now set, that's going to be our key to say the student is no longer active, but he's a graduate. And if that grad date is set, we want to push him into cloud storage. So I'm going to say archive alumni to cloud storage. And so the idea, again, is on the state transition, we can observe it in our mid-tier on our on-premise service, push it up into our cloud storage. And what I'm going to do here is paste in some code that's going to do that. And so let me go grab it right here. There we go. And before I do that, generally in a production system, you're not going to push right away from your mid-tier. You're going to probably take the code I'm about to paste in, put it into a side worker queue that's going to do that, and then maybe run a garbage collection task on your local store to clean out the alumni records, right? That's probably how you do it in a sort of a more of a distributed way. But for the sake of the demo and to keep the coolness factor up on the demo, let's just do it right in line so we can see everything happening. And so I'm going to paste in the code, and what I want you to notice is that we're going to be using the data service context class, which is the same class that we used from the Silverlight application to talk to our on-premise service. Now we're using that same class library to talk to a remote service, in this case, the SQL data service that's in the cloud. And so let's look at what's going on here. I'm pointing the service to the cloud, and it's going to store some alumni, and I've pre-created this account, and it's a SQL data service. You've got my credentials right there, so feel free to party on the account. Not yet, because if you do, the demo will bomb. So just not yet. The next call is just saying, hey, the cloud storage automatically does some version management for me. I don't care about that in this context, so I'm just telling the client library, hey, be a little lenient here. Don't worry about that. And then I'm adding this new cloud student up into the cloud, and you can see I've just instantiated the cloud student based on the change student. And when I call save changes, this is all we need to be able to push that student up into our SSDS account. So you can see same client library experience I used against my on-premise service, now I'm using against Cloud Store. So now that we've got this, the last step is to actually graduate a student, set their grad date so this guy gets fired. So remember that graduate button that was beside the students in the Silverlight application? We're going to go all the way back to the Silverlight app, hook up that grad button so that when we graduate somebody from the client tier, that changed student is going to be sent to our mid-tier on-premise service. Our on-premise service is going to be able to notice the state change from active to alumni and then archive the student up into the cloud using this code. So let's go back to the Silverlight app, and you can see I've got the handler already hooked up for that graduate button. It does nothing right now, so we need to paste in the code for this. So let me go grab it. It's right here. Most of the code is just the callback. And so let's paste this guy in and look at what we've done. We pasted it in the handler. The handler is getting the student that's bound to the button, so standard data binding again. The student that's bound to the button, I'm saying, are you really sure that this dude graduated? And yes or no. So if you say yes, then we're going to set the grad date to now on the local student. So this is all just in-memory operations on the Silverlight tier right now. We're marking the student as dirty, so we're telling that client library, just the same library we've been using all along, that the student is dirty. We disable the UI so that the UI kind of gets hazed out while the operation's in flight. And then we asynchronously send that changed student from our Silverlight code to our on-premise service. And then in the callback, which is student updated, shown here, we're just going to re-enable the UI and end the operation. So standard sort of begin-end pattern. And save this. And then again, what's going to happen is our code in our mid-tier is going to observe this, see the state transition, and push into the cloud. So let me save this guy. And if all goes well, we're going to do the whole dance right now. So let's run this guy now. And what I've done is I've set a breakpoint in the mid-tier on-premise service so we can actually see this sort of state transition from active alumni being observed. So we're going to log in as an admin so that we can actually change the student. We're going to go to our Silverlight app that is the new fandangled sort of experience for our university. There's all the folks. You can see myself, Pablo. If I click on me, we go retrieve the classes just as before. And if I zoom in on me, we can see I don't have a grad date set yet. So what we're going to do is graduate myself in this university by clicking the grad button. And when we do this, we should see the interceptor fire in the mid-tier on-premise service and hit our breakpoint. So I graduate. Are you sure? Yeah, I graduated. And so there we go. We just hit the breakpoint that's running in the mid-tier, which is the on-premise service we created. We're doing a role check to say, is that client on that, is that the person logged into that Silverlight app actually an admin? Yeah, I am. Has the grad date been set? Yes, so I'm now an alumni. And here we want to push that guy up into cloud storage. So I'm going to let this go. And hopefully the UI comes back, and did. And I have a little refresh problem in the demo, so let me just refresh the site and zoom in. And we can see the grad date is now set for me, right? And so what's happened is we've actually archived that student up into the cloud, right? And so to prove to you that this student has actually made it all the way into my SSDS account running in the Microsoft data centers, let's go and use the uniform interface from the browser to query for that student we just put there. So again, let's jump into my notes. And let's get a query here. So remember we called them cloud student. And Dawn explained a little bit about the URIs there. So we're going and we're saying, give me back the students that are tagged with cloud student. Using that same filter expression, they use basic HTTP auth. And so I'm going to ask for it. And we can see we've got a collection of alumni with one student in there, one entry element. And if I drill in, you can see there's a cloud student. And the date time of graduation is just now. We just executed it. So you can see I was able to actually archive that student up into the cloud. So there we go. So let me just jump out of the demo for a second here. And flip back into our slides. So short story here was we were able to integrate a building block service in the cloud to sort of offload some of the data management tasks that we didn't want to have to take care of ourselves. And our programming experience was the same programming experience against that cloud service that we were using to talk to our on-premise service. And so to summarize what we've looked at so far, what we've got is a set of services out there. They're services you create yourself, services third parties are creating, services that are created by Microsoft hosted up in our cloud infrastructure. And the idea here is that each one of them has different purpose in life, from domain specific through to building block. But the interface into those services is uniform. Again, how you interact with the data in the service, how you point at the data you want to work with using URIs, how you specify the action you want to take using gets, puts, posts, or delete. It's all sort of a uniform interface based on the AtomPub standard to talk to these services. And then from a developer perspective, what we get is we can build reusable developer tools, such as the add service reference gesture I showed you a second ago, reusable reporting tools, client libraries to talk to these services. So we sort of learn one set of libraries, learn one set of interactions, and can apply that across many of our services. And so far, we've just been consuming from the browser and from Silverlight, and then also from the mid-tier, which was running the .NET Framework. But hopefully, in using these services from the browser, I was able to show you that the interface into these services is really simple, just simple HTTP. So if you're on any platform, Microsoft or other, it's really easy, and it's easy to interoperate and get data from these particular services, because sort of the barrier to entry is just HTTP. And we've spent a lot of time making sure that that HTTP interface is very clean into these services. This is something that we're actively taking feedback on, so our thinking is that very much so the API for these services is that HTTP API. And if you're consuming these services from a Microsoft-based platform, we like you a little bit better. So what we end up doing is ship a bunch of high-level client libraries. And that's what we were playing with today. So we had the Silverlight library that we played with, the .NET Framework library that we were using. In the ASP.NET AJAX talk, you might have seen dynamic data. We've taught dynamic data to know about these types of services, so you can automatically take services from the cloud, bind it, and automatically have a site created. In the ASP.NET Futures talk that's going to come up, you'll see a lot of the things that we're doing with client-side data binding in AJAX that natively understand the conventions to talk to these services, so you can very, very easily take data from services and create your AJAX-style applications. In fact, we just shipped the first look at an AJAX library with client-side binding that know how to talk to these services up on the ASP.NET Codeplex site. And so that's a summary of what we've been able to see today. And we've talked about some of the new stuff as we've gone along, some of the new services. But I wanted to take just a second to look at the longer lead roadmap for these technologies. And so the first off is the framework technology. The framework included sort of the code that we needed to create our on-premise service, as well as some of the client libraries that we can use to talk to our on-premise service and others. And so some of the things we're thinking about in the framework space is that we're going to continue to make it even easier to get data from these services, build line-of-business applications, and bind that data to UIs. You'll see us make it further enhancements here. We're going to make it sort of easier and more efficient to work with really big content out of these services, both structured content and binary content. You can work with binary content today. We're going to continue to sort of embrace the AtomPub standard here and make it even easier to work with binary content using AtomPub media link entries. And then as well, so Don in the keynote a second ago had this Atom browser application that he showed. And the goal there was to show that, hey, we're just using feeds. And since he's got a basic Atom browser, he can consume those feeds. But what we found is there's a lot of tools that are able to consume feeds. In fact, there's a lot of tools that are taking it one step further and saying, if a feed has a well-known microformat inside of it, then I'm going to understand that microformat and do something interesting. The best example I've seen is sort of the Live Earth Maps site that knows how to take feed data with microformats that's got GeoRSS information, and then take the data from the feed and sort of plop that down on the map. And so we're going to make those types of scenarios even easier with the services that you create using the Data Services Framework. And lastly, so far, we've been required to sort of have a connection to each one of these services as we've been talking to them. We've been using client libraries that are connected libraries. They make requests in the back end to the service to pull data. What we're doing is we're taking the Data Services Framework, and we're working on a project right now that we're dubbing Astoria Offline that effectively makes it very, very easy to work with one of these data services even when you're not connected to them. And the idea is that you can pull down the data you want from the service, work on it locally, and then sync back up at a later time when you're ready to go. So the best way I can describe it is make it super simple to build an Outlook-style application. You know, you can keep working with your email when you're on the plane and then sync up later. Make it what we're going to do is make it really, really easy for you to build that style of application when you're talking with data services. And then on the last piece is just the conventions that you use to talk to these services. We've taken a lot of feedback. We continue to take feedback here. And so we're going to continue to increase the paging semantics that we have, which means that you don't have to ask for a whole set of data, like all the classes at once. You can ask for just the set you want, or the server can enforce the size that you can ask for. We have client-side paging today in the bits. Server-side paging is something we're looking to add. A lot of folks gave us feedback. It would be nice to be able to get how many results are in a collection without actually getting the collection. And so what we're looking at is basically giving you a way to quickly get the count so you can do even more complicated data binding to grid type scenarios. And then we're looking at adding in sort of containment type pieces where we say an order is contained within a customer, you can only get to the order through a customer, and so on. And so if you have feedback in this area, this is definitely something that we're currently looking at this point. And this slide is sort of the pretty marketing slide, clearly not created by me, but basically it's a picture to say we're continuing to take all this sort of data service investments that we've made and sort of aligning them with a set of shared conventions so that you get a sort of a uniform developer experience, uniform set of tools to talk to services. This slide is showing that the SQL Server data service that we looked at plus the data services we created are aligning against the same set of conventions. And in fact, the service that I was working with today in SQL Data Services is now available via CTP form, and you can go sign up for an account today and create your own account and work with the SSDS account, an SSDS account, just as I was here today. And so last step, so almost done. I know I'm just getting in on time. So the last piece is if you're still awake and you're still interested in this technology, then if you want to get more involved, the team has taken a very sort of transparent approach to how we've been building out these systems. And the idea is that we get some feedback, we start designing the feature as a group. This is one of our outdoor summer design meetings here. And once we get all the notes down on the whiteboard and all of our thoughts down on the whiteboard, we basically take the notes off the whiteboard and put them on our blog. Before we spec'd it, before we've designed it, and we say, hey, this is what we're thinking about, what do you think? And so if you're interested, watch for the design notes on the team blog, give us feedback. And if you jump on one of the posts early, it's more likely that your feedback will help us shape sort of the next piece of the project. And if you start reading the design notes and you get really bored partway through, we've started posting little videos along with the notes about what we're thinking. And the team likes to have some fun with those of us that are recording the videos and ask us weird questions. So at the very least, the video will be funny if the design notes aren't interesting. And so with that, I just want to say thank you very much for your time. I very much appreciated it. Here's some resources if you want to learn more, and I'm happy to take any questions that you have. Go ahead. We had one question over here.
Yeah. I was wondering what your support for date time offset is.
Sorry, could you repeat the question?
What your support for date time offset is?
Sure. So in general, any of the new SQL Server 2008 types aren't yet supported in the framework, but it's something that we're looking at.
Is there any workaround?
Not yet.
You also used an expand method in your sample. Is that in the current release?
Yeah. So question was, I used the expand method, which let me sort of eager load relationships. Absolutely, fully supported in the bits that are released today. So I'll take one more over here, and then we'll sort of come back. Go ahead.
Yes, you mentioned that you were going to talk about concurrency some, and I don't think that got mentioned much.
Sure. So on the concurrency side, what you can do is you can take the data model that was driving our service, and using the entity framework, you can tag some of the properties as being, these are the properties that make up the concurrency token for a particular entity. And once you've tagged those properties in the model, the data services framework is able to sort of read those special properties as being your concurrency token, and then we handle sort of optimistic concurrency for you using just basic HTTP e-tags. So conditional requests in HTTP is sort of the approach we take for optimistic concurrency.
Okay, and any support for the version match and if match in the header,
yep,
like there is in SQL Data Services?
Yep. So basically what ends up happening is once you have defined that concurrency token for us, the system's smart enough to automatically pick them up and generate those if match, if none match headers for you. E-tags come back, standard dance. Yeah. Is there anybody here? One more? Yeah.
Yeah. Could you describe the relationship between Oslo and what you're doing?
Sure. So question was relationship between Oslo and what we're doing here. So the idea is that we're able to go from a model to a service tier pretty quickly. Oslo gives us a bunch of rich capabilities around modeling, so we're working together to see how that can span out over time to be able to use some of the richness of Oslo to help generate these types of services. So it's still early, but you'll see more from us in this space. Yeah.
If I have to support an Oracle backend, how much of what I saw today can I still use?
Great. So the question was, what if I want to have an Oracle backend? What's the deal? So the system itself that we used to create an on-premise service is layered. And the way the layering works is that we basically had the data services framework. The way we talked to the underlying SQL server was through the entity framework in this case. The entity framework has a provider layer that you can plug in support for various backends. And so they have providers for Oracle, I believe, are already available, right, guys? Yeah. So basically, all what we saw today, you could do over an Oracle store.
Thank you.
Any more questions that we had? One more in the middle here.
I saw on one of the slides that part of the REST format seemed to have class/member. Is that new?
Yeah. So what we support in on-premise services, and we're starting to bring into some of the cloud services as well, is sort of deep access. The idea of going from a set to a single thing and then drill within that thing. The on-premise framework fully supports that today. Some of the cloud services do, some of them don't yet.
Okay, and if you have a subclass, a relationship that's the same name as a property, a member, how do you differentiate?
Sure.
Is that the dollar value? Or?
Yeah. So how do you differentiate between the two? Basically, right now is you have to have annotated which one is a special navigation property to us, and then we're able to sort of understand the fact that it's a navigation and not a primitive property access. And so basically, just like you can't have two properties that collide on a .NET type, same kind of concept applies to the interface here. One more?
So do you provide any support for versioning of your resources?
Sure. So questions around, do we support any type of versioning? We do. And the approach we tried to take was just simple HTTP headers to be able to negotiate version. And what we recognize is that most clients on the web, you don't know who all of your clients of your service are. My best example is MSN Messenger. Always, when I'm at work, I look over at my colleagues, and we're all running a different version of Messenger, all talking sort of back to the same Messenger service. So the approach we took with versioning is that you don't know who all of your clients are, so we tried wherever possible to make it super simple for down-level client libraries to talk to sort of up-level services, and then down-levels and vice versa. And obviously that breaks down in some cases, and so there's cases where you sort of hit the line and you have to version using a new URI endpoint, but we sort of are cognizant of that, and we've got a whole kind of workflow in terms of what you can safely version within band and keep compatible, and what sort of crosses that line where you just have made a breaking change and you need to think otherwise. What I'd like to point out, though, is that our versioning scheme handles the interaction for you. At the data model level, if you start changing the data model that you're exposing, we don't version that for you. Basically, you're the one who knows best about your data model, so we give that to you and also give some guidance. Yeah. Question over here?
Yeah, how do you handle the distributed transactions?
Sorry?
The distributed transactions?
Sure. So today in the system, there's no sort of inherent support around distributed transactions. What we've tried to do is layer it in such a way that you can start to take our framework as a building block and then plug in pieces around it. We'll have sort of more guidance as we go in this space, but right now the idea is that you'll use compensating actions and not hold locks sort of in a distributed way. So the idea is that there's not sort of direct support out of the system, but you can sort of plug in some of the pieces and augment some of the pieces as you go.
Does Microsoft continue to invest its time and money on link to SQL with ADO, .NET Data Services, and Entity Framework coming into picture? Sure. Is there any support for link to SQL in coming days?
Sure. So question was, what's the support for link to SQL? Basically, the approach we've taken from the data services standpoint is we had two key scenarios. The first one was a service over relational database via a model. And the second was a service over any type of other store. So the framework we use today supports both scenarios. And sort of deriving a service from a model works very well over the entity framework for us, because that's sort of the key point. So from a data services standpoint, we get sort of the scenario of a service over a model through the entity framework. You can plug in link to SQL today through using our APIs, but we don't provide that hookup directly. And so there's only sort of so many hookups we can provide out of the box, and what we're trying to do is provide a rich interface so you can plug in any data source that makes sense for you, whether it be an existing investment in link to SQL or others.
In your query interceptor method, you controlled access for single entity. But what if you want to apply the same logic to to multiple entities?
Okay. So is the question around what if I wanted to apply it to students and classes and different types?
Yes. Do I need to copy the same function over and over again?
So the idea is that you provide an interceptor for each set you're exposing in the system. So one for students, one for classes, and so on. We're looking in V2 as a way to sort of provide one interception point for many sets, but that's not supported in the bits that are publicly released today. The bits that are released today, you would create a different one for every set that you're exposing out of your model.
Okay. Another question is, how do you do the undo changes? Because your context is kind of tracking the changes of all your objects. But at some point, if I want to say discard all the changes I have made, I haven't found any method on it.
So the question was around if you're using the client-side context, is that correct?
Yeah, client-side.
Yes.
Yes.
So today in Astoria, on the client side, or I keep using our old code name, in ADO.NET Data Services Framework in the client side, if you want to discard the changes you made, you either have to explicitly tell us about that through API calls, so like delete link or delete object or something like that, or discard the context completely and start with a new one. There's no rollback changes to a particular point API. The idea is that we went really low level to support sort of pure POCO classes, meaning we put no requirements on your classes. Just like you used add service reference to generate classes, you could hand type your own and use them in the system.
So basically, I need to keep track of all the changes I have
Yeah,
made.
if you want to roll back, you need to make API calls to roll them back.
Oh, okay. Great. Thanks.
So one more question. The network is inherently unreliable. If you do a post operation to actually modify your data store by adding a resource, how can you be sure that it actually occurs and occurs only once if you need to retry?
So you're saying, how do we get exactly once semantics?
That's correct.
Yeah. So the way the system works is they provide sort of the base communication mechanism for you. If you want to layer in exactly once semantics, you can do that, but you would have to add that in yourself, maybe using a version token for the message or something like that. It's in the same way other WS standards have done it in the past. And usually you'd pass that type of out-of-band information through just basic HTTP headers, and all the client libraries provide support for doing things like that, passing extra out-of-band information through headers and reading them back. But that's something you would have to layer on the system today, but I'd love to talk with you more about it if you'd like to see something like that in a future rev.
Any support for other aggregates beyond count?
Good question. So any support for other aggregates? We're looking at that. We're looking at how do we support even richer query against these services. Not all services will be able to support such rich query. Database style services probably will, others won't. Not yet today in the system, to answer your specific question. We don't support others today. But we're looking at, in future, how we can provide a much richer query experience over these types of services, including aggregates and potentially joins and projection, and we'll see how we go. Yeah.
So you have, in your demo, you have pushed the students who have graduated into the cloud, right? So where does those objects live? In memory or in the SQL data store?
So when we archived that student up in the cloud, sort of we caught the state transition in the mid-tier, and at that point, the cloud student instance was just in memory. And then when we called save changes on the client code, what ended up happening is we made it under the covers, we made an HTTP post operation to SQL Data Services, and then that cloud student is being persisted in the SQL Data Services store. So literally there's a cloud student right now sitting in SQL Data Services data centers under my account, and there's one student sitting there right now. In fact,
so where does this? I mean, how does it get stored? Where is the schema for that cloud student?
Sure. So, sort of, what's the storage model for SQL Data Services? They basically have sort of a flex entity storage model where you can put in an entity. An entity can be of sort of arbitrary shape. It's not a schematized store today. I don't want to go too much in the details of SQL Data Services storage because there's a number of SQL Data Services talks here where they'll dig into the uber details of storage for you. And so what I was going to do is let me just grab a couple of these guys here for the folks that are still interested. Looks like I have a minute. And if you're interested in playing with the account that we used today, I think we were using alumni, right? Go ahead, play with my account. So this is the account we were using during the talk. Let me zoom in so everybody can see what's going on. There's the sort of username, password, very long. Go ahead, try it out, query the data that we just put up into the store. In fact, go try and insert a new customer, a new cloud student. And one of the things our community PM noted to me was, hey, wouldn't it be great if somebody else was able to put a cloud student in there before the end of the day? So if anybody is able to put a cloud student into my account before the end of the day, email me what you put in, and we'll find a sort of a prize for you. We have a few USB sticks to give away. So first person to get a new cloud student up into my account in SSDS, send me an email. It's just mflasco@microsoft.com saying what you put in there. I'm going to go look to make sure it's there, and if it is, we'll find you at the conference and give you something. So, go ahead, another question?
I have a quick question that I'm using Silverlight as a client. The question here is that in what scenario I should use WCF versus data service?
Sure. So the question was, what about WCF instead of data services? The way we've gone is that the data service framework actually builds on top of WCF. More specifically, it builds on top of the REST support that was introduced by WCF. So if you want to use sort of the same approach Don was taking a second ago to talk to one of these REST services, go ahead. It's not a SOAP-based system because we're talking about just pure data access here. It's still REST, but if you want to use any of the WCF classes like syndication item, syndication feed for talking to REST-based services that they have, go ahead. It just works. Yeah. Anything else?
Yeah, I wanted to ask one of my earlier questions a little different, see if the answer's a little different.
Okay.
About date time offset, you said you don't support any SQL Server types. What about if the date time offset is a CLR type on the model?
Sure. So even if you can map some of the 2008 types into the model, we sort of have a set of a type system that we understand and that all of the services understand. And right now, we don't support some of the newer types.
Still no.
Yeah. Cool. Well, thanks everybody for your time. I appreciate it.